everyone. My name is Sonia Lamba and I am assistant professor in Department of Computer Science in ABES Engineering College. And today's topic of discussion is propositions and logical connectives. Basically, we will discuss today what is a proposition and how to form the compound proposition using the various logical connectives. So, first of all, we need to discuss what is a proposition or a statement is. So, a proposition or statement is one and the same thing, and a proposition is a sentence, or we can say a declarative sentence, whose value can be either true or false, but not both. So, at a time, value of a proposition or a statement can either be true or false, but not both at the same time. For example, 3 plus 3 equals 6. So value of this statement can be either true or false, but not both at the same time. So here we can see that 3 plus 3 is not equals to 7. So this statement is false. Statement is not true. Okay, so next, propositions are generally represented with the help of the lowercase letters. Like we can use P, we can use Q, we can use any lowercase letter to represent a proposition, and at that time, that letter is said to be the proposition variable. So, proposition variable value at a time can be true or false. So, if the value is true, we say that the value will be denoted by 1, and if the value is false, it means the value is 0. So, if we have a proposition like the sun sets in the east, and we have denoted this proposition with the help of the proposition variable p, so we can say that P is true or P is false. But we know that the sun sets in the west, so proposition is false. And in that case, we can say that the value of variable P is 0, or value of variable P is false. So in that case, proposition variable P, which is denoting the statement that the sun sets in the east, is false. So a proposition is a statement whose value can be either true or false, but not both at the same time. So now we have to discuss the types of propositions. So generally we have two types of proposition: a primitive proposition or primary proposition, and the composite proposition. So if we cannot broken down the proposition into the simpler proposition at that time, we will say that the proposition is simpler one, proposition is primitive, proposition is primary. But if we can break down a proposition into different proposition, at that time we will say that the proposition is the composite one, proposition is the compound proposition. Or in other words, we can say that if two or more propositions are combined together with the help of logical connectors or connectives to form a new proposition, at that time also we will say that the proposition is a compound proposition. Now we have five types of logical connectives with the help of which we can form a compound proposition. So the words or the phrases, or we can say the symbols that are used to form the compound proposition, are said to be the logical connectives. And we have the five connectives known as negation, conjunction, disjunction, conditional, and biconditional. So these are the five connectives with the help of which we can form the compound proposition. So now we will going to discuss the first type of connective, which is the negation one. Negation connective is denoted with the help of this tilde symbol. Now, if we will say that P is the proposition variable which is denoting to one of the proposition, and we need to identify the negation of that proposition, then the negation will be denoted like this: tilde symbol followed by the name of the proposition variable, and will be read as not P. So for example, if P is the proposition variable denoting to the statement that the Paris is in France, and if we need to find out the negation of this proposition P, then the negation will be denoted by till P, and the statement will be, it is not the case that the Paris is in France, or we can say that the Paris is not in France, which is the negation of the given statement. Okay, so if we will be talking about the truth table for the negation connective, so initially the value of a proposition can be either true or false. So if the proposition P is by default true, then the negation of proposition will become false, and if the value of the proposition is false, then the negation of that proposition will denote the true value then. So this is the first logical connective, which is denoted with the help of tilde symbol, and the connective name is the negation. Next, we have the another logical connective, which is known as the conjunction and will be denoted with the help of this symbol. So let us suppose if we have the two proposition variable denoting two different proposition, and we need to identify the conjunction of these two proposition, then the conjunction will be read as N, P and Q. If we will write like this, P conjunction Q, then it will be read as P and Q. For example, if we have two proposition, let's say P is saying that Ram is healthy, and proposition Q is denoting to the statement he has blue eyes, and we have to find out the conjunction of these two proposition P and Q, then the conjunction will become a new proposition, which is a compound proposition, and the proposition will become Ram is healthy, and because conjunction will be read as and he has blue eyes. And if we will be talking about the truth table of the conjunction connective, so if two variables are there, then maximum four possible cases will be there. True, 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 false, false, true, and false, false. So conjunction says if both the proposition variables are true, then only the result will be true, otherwise result will be false one. So this is the second logical connective known as the conjunction. Next we have the third type of logical connective, which is the disjunction, and disjunction will be denoted with the help of the symbol V. Now let us suppose if we have the two propositions P and Q, and we need to identify the disjunction of P and Q, then the disjunction of P and Q will be the compound proposition and will be denoted like this symbolically, P disjunction Q, and will be read as P or Q. Disjunction will always be read as or, and conjunction will always be read as and. So for example, if we have two proposition variables denoting to two different statements, let's say P is denoting to the statement it is cold, and Q is denoting to the statement it is raining, and we have to find out the disjunction of P or Q, then P or Q will be denoted like this and will be the new compound proposition, which is known as it is cold or raining. Now we have discussed earlier also that disjunction will be read as or and conjunction will be read as in. Now, if we will be talking about the truth table, so if two propositions will be there, then maximum four possible cases we can have is true, 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 false, false, true, and false, false. So if we need to find the P or Q, P disjunction Q, now in case of disjunction, the result will be false if and only if both the propositions are false, otherwise the result will be the true one. So this is the truth table corresponding to the disjunction logical connective, and disjunction logical connective will be read as or. Next is the fourth type of logical connective, conditional, and conditional will be denoted with the help of this arrow symbol. Now let us suppose if we have the two propositions P and Q, and we need to identify the compound proposition formed using the conditional connective, then the compound proposition which is formed using the conditional connective will be read as if P then Q. In this case, proposition P is called the antecedent or hypothesis, and proposition Q is called the consequent or the conclusion. P is the hypothesis and Q is the conclusion, and if this logical connective between these two proposition is conditional, in that case conditional logical connective will be read as if P then Q. Now we can see the truth table. In this truth table, the P implies Q or P conditional Q is false when P is true and Q is false. So when P is true and Q is false, in this case only the P implies Q result will be false, otherwise the result will be the true one. So this is the truth table corresponding to the conditional logical connector. Now we will take one example also, like P and Q are the two propositions. Proposition P is it rains and proposition Q is I will carry an umbrella, and we have to form the compound proposition with the help of the logical connective conditional or or with the help of the conditional or implies. So in that case the compound proposition that will be formed is if it rains then I will carry an umbrella, as I have discussed earlier also, that conditional connective will be read as if P then Q. So here if it rains then Q, I will carry an umbrella. So this is the fourth connective. Now we have the fifth logical connective or the logical operation with the help of which we can form the compound proposition. Now if we have the two statements or two propositions, then the compound proposition formed with the help of this biconditional will be read as P if and only if Q. Now, this is the truth table corresponding to the biconditional logical connective. Now, in this case, result will be true when both the proposition values are same. So, if we can see here, if P is true and Q is true, then only the result will be true. And if P is false and Q is false, then also the result will be true. Otherwise, the result will be false. So, if both the proposition values are same, either both are true or either both are false, in that case only we will get the true, otherwise we will get the false value. So this is the truth table corresponding to the biconditional logical connective. Now here we take an example also. Let's suppose we have the two propositions P and Q. Proposition P, let's say, is he swims, and proposition Q is water is warm. And we have already discussed that this is the symbol double-sided arrow for the biconditional logical connective. And here we are forming the compound proposition with the help of this biconditional logic connective. And this biconditional logical connective will be read as if and only if. So P is he swims if and only if Q is water is warm. So the compound proposition that will be formed using the biconditional logical connective between proposition P and Q will be he swims if and only if water is warm. So all these are the five logical connectives that are used to form the compound proposition with the help of the simple propositions. Now, next is the logical equivalence. Now, we can have the two propositions, and these two propositions are said to be logically equivalent if and only if their corresponding truth values are same, or P biconditional Q is a tautology. Then only we will say that these two propositions are logically equivalent. Otherwise, we will say that these two propositions are not logically equivalent. So when we have to prove that these two propositions are logically equivalent or not, so this is the symbol to represent the logical equivalence between the two propositions. For example, we have taken one example also, like in the left hand side we have P biconditional Q, and we have to prove that this left hand side is logically equivalent to right hand side, which is P or Q conditional P and Q, with the help of the truth table. So what we have to do is we have to prepare the truth table. We can see here in this expression, only two variables are there, P and Q. So based on the two variables, only four possible cases will be there: true, 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 false, false, true, and false, false. So here, first we need to solve these two brackets, P and Q, as we have discussed that the conjunction connective will return true if and only if both the proposition are true, otherwise it will return false. So now we have to take the negation of this P conjunction Q. Negation is if the value of the proposition is true, it will become false, and if the value is by default false, it will become true. So this is the negation. Now we have solve the bracket. Now we have to check the value of the negation P and negation Q, and we have to perform the OR operation over these two P, negation P and negation Q. When we have performed the OR operation, disjunction operation over negation P and negation Q, we have find that false, true, true, true. Now we can see that negation of P conjunction Q is logically equivalent to negation P or negation Q, because we can see here the corresponding truth values are same. When P is true and Q is true, the value of this expression is false and the value of this expression is also false. When P is true and Q is false, the value of this expression is true, and here also we can say the value of this expression is also true. So here we can see that the corresponding truth values are same. Now we can say that these two propositions are logically equivalent. So two propositions are said to be logically equivalent if and only if the corresponding truth values are same, either the corresponding truth values are same, or we can find the P biconditional Q, and we can see that if in the last column all the truth values are true, which is said to be the tautology, then also we can say that two propositions are logically equivalent. So today we will discuss, we have discussed about the proposition or the declarative statement. We have discussed about the different connectives that are used to form the compound proposition, and when we will say that the two propositions are logically equivalent. So that's all for today. Thank you.